Okay. So that looks like some roads in Mexico. All right, did you finish looking at that? All right. So we really need to understand and use the inverse sine function, inverse cosine, inverse tangent, and then be able to use a calculator to evaluate these. And then find exact values of composite functions with inverse trig functions. So we're going to do that. So you need to remember some things about inverse functions from Math 1710 is that it's a horizontal line test for inverses. If no horizontal line intersects a graph of function more than once, the function is one-to-one and has an inverse. And so also if you got the point AB on the graph of F, then the point BA is on the graph of the inverse function, denoted F inverse. So this is just a review. So in 4.7 class note, the horizontal line test says if no horizontal line intersects the graph of a function more than once, then the function is one-to-one and has an inverse. And when we talk about inverses, they have to be functions. It has to be a function, it says that right there. So, and if the point AB is on the graph of F, then the point BA, just switch your X and Y coordinates, just switch these, switch your X's and Y. So that point then is on the graph of the inverse functions, and it's denoted, the inverse function is denoted F inverse of X. We say F inverse. It's not 1 over F. It's not an exponent there, it's a notation. Okay, and that's straight out of the notes. Oh, and the graph of F inverse is the reflection of the graph of F about the line Y equals X. So, an inverse is a reflection of the graph F across the line Y equals X. That was this line. That's a line. An inverse sine is denoted by Y equals sine inverse sine of X, or Y equals arc sine of X. Sometimes we use arc. Some calculators use arc sine. It means the angle whose sine is X. That's what inverse sine means, or arc sine. That's the notation. So it doesn't mean, when you see this notation, it doesn't mean that this is 1 over sine X. It's the inverse notation. Okay, now we're going to look at the sine function here on our slideshow. And if we draw a horizontal line there, do we go through more than one point?
Yeah.
Yeah, so it's not one-to-one. So you have to memorize these restricted domains. So we're going to restrict the domain for the sine function to be from minus pi over 2 to pi over 2, from here to here, and then it will have an inverse. We're just using this part of the graph. So we have to restrict the domain. So it is not 1-to-1. The sine has, but the sine x will have an inverse function on the restricted domain minus pi over 2 less or equal to x less or equal to pi over 2. All right, and then we're repeating. So we're restricting the domain from here to here, and now it will have an inverse on that restricted domain. Okay, inverse sine function has a restricted domain. You have to memorize this. So y equals inverse sine of x means sine of y equals x. Okay, I'll continue writing. So you have to memorize this. You have to know what those restricted domains are. So therefore, y equals inverse sine of x means sine y equals x. Where y, the angle is between minus pi, so y is an angle, x is a number. Got to get those straight. We take sines of angles and we get numbers. So y here is an angle and it has to go here between minus pi over 2. We have to get something out in this area. And x is going to be between minus 1 and 1. When you take the sine of an angle, it's always between minus 1 and 1 inclusive. So remember, y equals inverse sine of x is not equal to 1 over sine x. Y equals 1 over sine x is written as sine of x to the negative 1 power. Okay? And it's equal to cosecant x. So the inverse sine function has a domain of minus 1 to 1 and a range of minus pi over 2 to pi over 2. Okay, so that's the inverse sine function, and we're going to look at some pictures. Back at some pictures here. So one way we can graph y equals inverse sine of x is to take points from the graph of y equals sine x and switch the order of the coordinates. So minus pi over 2 minus 1 becomes minus 1 minus pi over 2. So this is y equals inverse sine of x over here. So that's what the next slide says, that we can reverse the order of the coordinates. And so we switch the order. When you switch 0, 0, we still get 0, 0. So this is y equals inverse sine of x. And remember that the range and the domain get switched on inverse functions back from Math 1710. Okay? Another way we could get it is we could reflect the graph of the restricted sine function about the line y equals x. Which is probably going to be easier to switch them, but so we can reflect the graph of the restricted sine function about the line y equals x. So I've filled in, that's what we're supposed to write in your notes in those two slides. Reverse, reflect y equals x. I think reversing the order of the coordinates is a really handy way to do it. Okay? So let's find some exact values of inverse sine. You can either use a table, you can use your unit circle. So how do we do that? We let theta equals inverse sine of x. Rewrite it as theta equals inverse sine of x as sine theta equals x. And then you need to remember that angle has to be restricted to be between, for sine function, between minus pi over 2 and pi over 2. And we'll use exact values in the table or unit circle to find the value of theta in minus pi over 2 to pi over 2 that satisfies sine theta equals x. Okay, so there's a table. We have our unit circle. You can find it. So we're going to do an example. I brought a unit circle. Sure. Where's the unit circle? Okay. So we're going to find the exact value of inverse sine of the square root of 3 over 2. So it goes to the next page. So first we're going to rewrite this as theta equals this. We're going to get an angle. And then rewrite it, so we'll say theta equals and then you're going to rewrite it as sine theta equals the square root of 3 over 2. And remember, theta has to be between, well, I'll just write it like this. Minus pi over 2 less or equal to pi over 2 theta. So look at our unit circle. our angles of, here's our unit circle, minus pi over 2 to pi over 2 is here. So look at where sine, that's the y coordinate, equals positive square root of 3 over 2, right here. The angle is pi over 3. So we use the table or the unit circle. The angle in between minus pi over 2 and pi over 2, whose sine is square root of 3 over 2, is pi over 3. We looked it up. So
what makes it not 120 degrees or pi over 3?
Because we've restricted the domain, the angle has to be between minus pi over 2 and pi over 2. So we find that's why it's not over here. Here, not that one. Has to be between here and here for sine. So, okay. So that's why you have to memorize this for sine. Okay. All right. So we've done that one, and you can also use a table, but we've got the unit circle that I gave you. So you use the unit circle. Here's the values. You find where sine theta equals positive square root of 3 over 2. In a table, it's pi over 3. All right, the next example. So here's the next example. And you should write these steps down. Don't skip these steps. This means that theta equals inverse sine of minus square root of 2 over 2. And then you rewrite it as, that means sine theta has to equal negative square root of 2 over 2. And then look in the unit circle to find the exact value of theta in minus pi over 2 to pi over 2. So we're going to look at our unit circle. To find between minus pi over 2 and pi over 2, minus theta is minus square root of 2 over 2. Remember, this is minus pi over 4. I have it written. I probably used this. Remember, we have to go from minus pi over 2 to pi over 2. So you'll have to rewrite these angles as negatives here. So the answer is minus pi over 4. Theta equals minus pi over 4. Let's see. Okay, so, and because the domain of the inverse sine function is minus 1, 1, you can only evaluate inverse sine x for values of x in this domain. So there is no angle whose sine is 2. You're not going to find that. No angle whose sine is more than 1, or less than negative 1. And that's showing you with the table, okay. So we've got, so there'd be no solution if you're told, or if you've got sine inverse of x equals 2, that would be no solution. That's what this is saying. All right, and then we're going to do cosine. Again, by the horizontal line test, the cosine function, okay, so there's a mistake in your notes here. It's the cosine function is not 1-to-1. Y equals cosine x does not have an inverse, or it does have an inverse though if we restrict the domain from 0 to pi. So we've chosen to restrict it from 0 to pi. So there it is. It's the cosine function is not 1-to-1, but if we restrict the domain to 0 to pi, it is 1-to-1. And that's what we do. We restrict the domain. So the inverse cosine function, and that's what that equals. So I'll fill in these. So the inverse cosine function is written as and it means x equals cosine y, where y is the angle is between 0 and pi, and x is between -1 and 1. There's the inverse cosine function has a domain of -1 to 1 and a range of 0 to pi. Okay? And again, you have to memorize the restricted domain of cosine. Memorize that. Okay. Did I already write all that? Oh, one way to graph it. Okay, so I've written all that. And again, reversing the coordinates is a great way to graph this. Graph that part of the cosine function. Reverse the coordinates. Here's the inverse. So one way to graph is inverse cosine is to reverse the order of the coordinates of points on the restricted domain for cosine x. Another way is to reflect the graph about the line y equals x. So we're going to find some exact values of inverse cosine. The steps are the same for sine. So I'm just going to go on. We're doing this example, that's the steps. We'll do it. So, to find exact values of inverse cosine of x, we let theta equals inverse cosine of x. Rewrite that as cosine theta equals x. And then you need to make sure that theta is between 0 and pi. And then the third thing is then we're going to use a table, or we provide you the unit circle, so we're going to use the unit circle to find the value of theta in 0 to pi. use a table or the unit circle to find the value of theta in 0. So here's an example. We're going to find the exact value of inverse cosine of negative theta. So you just write theta equals inverse cosine of negative 1/2. And then you rewrite it as cosine theta equals negative 1/2. And then we're going to use the unit circle to find theta equals we're going to look at the unit circle between 0 and pi and find what theta equals. So now we don't have to rewrite things as negatives. Let's see. We're going between 0 and pi. We're looking for x is negative 1/2. Between 0 and pi, negative 1/2 is up here. That's 2 pi over 3. 2 pi over 3. So that's sine and cosine, and that's how to find exact values with the unit circle. Now we're going to talk about tangent. All right, so we'll look at tangent function. Okay. There's finding that one. Here's the tangent. So we got all these. It's repeating. So it's not 1-to-1 either. So we got to restrict the domain, and we're going to restrict it to minus pi over 2 and pi over 2, but regular parentheses, not square brackets, because these are for classical. So we're going to restrict the domain. It is not 1-to-1, so it does have an inverse function on the restricted domain, minus pi over 2 to pi over 2. You have to memorize that. You have to know that the tangent function has that restricted domain. And y equals inverse tangent of x means tangent of y equals x, where y, the angle, is between minus pi over 2 and pi over 2, and x is minus infinity to infinity. The inverse tangent function has a domain of all the real numbers, that's our x, so you can just write it as r, and a range of minus pi over 2 to pi over 2. And then and so one way to graph it is to take points of the graph and reverse the order of from the restricted tangent function. Or you can flip it across the line, y equals x. Okay, and it's the same thing. How we find an exact value of inverse tangent of x? Let theta equals inverse tangent of x, rewrite as tangent theta equals x, where theta has to be between minus pi over 2 and pi over 2. And then we're going to use a table, or we're going to use the unit circle, because I'm going to give you the unit circle to find it. So We've just gone through a whole bunch of slides, because it's the same, really. Except you just need to memorize this restricted domain. We flip them, and that's what we get. Y equals inverse tangent of x, just like that. Or, oh yeah, they didn't bother flipping it that way. It's just easier to switch the coordinates. All right, and these were the steps. Make sure that theta, there's a typo here on the slide. You have to make sure that theta, x is a number, theta is an angle. The angle has to be between minus pi over 2 and pi over 2. All right, so here's an example. Find the exact value of inverse tangent of x if theta equals inverse tangent of -1. Then you rewrite, so no, this is not written right. Okay, it's not written yet. Here's the problem. This is the original problem. You have to set theta equal to it, and then you rewrite it as tangent theta equals -1. But you do need to remember that you're between minus pi over 2 and pi over 2. Tangent on the unit circle, tangent theta is sine theta over cosine theta. That's y over x. So you're going to, where is y over x equal to -1? I've got the answer here. You remember, this is minus pi over 2 down here. This is minus pi over 4. So when you put these on top of each other, same numbers, a negative sign, that's -1. So it's minus pi over 4. The answer is theta equals minus pi over 4.
Negative positive 1?
What?
If you put the sine over cosine for the y over x, wouldn't they give you positive 1 for that one?
On that one, no. Okay. So if you were up here at positive pi over 4, you'd get positive 1. But at negative pi over 4, you get minus square root of 2 over 2 over square root of 2 over 2. It's negative 1. There's a minus sign here.
It doesn't.
Do I need to write that out?
Well, no, it's just don't the two negatives make a positive.
We don't have two negatives.
Oh.
Oh,
you're right.
the coordinates. Okay, so
I get it
it's
now. Sorry.
minus square root of 2 over 2 over positive square root of 2 over 2 is -1. So we had to take that, and if you need to write it out, I mean, you can write on the unit circle I give you. If you want to write. Okay. All right, and let's see, I think I have more slides showing. And then they found it to be minus pi over 4. And they actually found tangent theta. You could find the tangents on your unit circle. You do need to have that memorized. It's sine over cosine y over x. Here's the graphs of the three basic inverse trig functions. So on the filled-in notes, I wrote this out, and that's posted. I kind of wrote it all out. Yeah, I don't feel like writing. You can see the filled-in notes. I have sine, has a restricted domain. And you have to memorize this. And the period of sine and cosine is 2 pi, and the period of tangent is pi. And that's from the filled-in notes. That's basically, if you memorize that, you're going to do well with the inverse function, inverse trig function. So then we're going to use a calculator to find those. Okay. So that was that picture. And we're going to use a calculator to find things. So are you copying that, or you got it? You got it on the filled-in notes. So you can, this stuff is the filled-in notes that I posted has this right above 18. So they're copying it right now. Let's go on. So don't confuse your domains with the intervals of one period. So now we're going to use a calculator to evaluate inverse trig functions. It's second sine or second cosine or second tangent. You get, it says above there that you get, this is what's written above those. Okay. Now, we are finding it in radians. So mode equals radian, and that's why we want 4 decimal places. I would tell you it's in radians, but we're gonna be using radians. And then you're just gonna, to find this, you're gonna press second cosine, which is cosine inverse, or inverse cosine, and 1 divided by 3. Enter. But this is radian, so see, we're finding an angle. Yeah. 1/3 is a number, and minus 35.85 is a number. So go to our calculator, turn it on. Second, oh wait a minute before I do that, mode, radius, second width, and then second inverse cosine of 1 divided by 3. And they want 4 decimal places. So that's 1.231. And that's in radian. It's an angle. This is a number. This looks like an angle, but it's a number. And then we're going to do second tangent. And that's negative 35.85. And we get negative 1.5429 radian. So these are numbers, and these are angles. You got to get straight. What are angles and what are numbers? That's why we can say theta equals to help you know that that we're finding an angle. Theta equals to help you with that. All right, and we will. I never took roll today, so I'm going to pause it right now. All right, so So we found those, and we prefer radians. Okay, so these are the inverse properties of sine and its inverse. And I'm going to be filling that in a second. Let me go into Shobi really quickly. We're going to change the due date. Well, I'm thinking about it. And I should change the name of that worksheet too. Because that, but we'll see. So this is really 4, 5, yeah, 4, 7. It's got something from 4, 5, and then something from 4. Or 4, 6, and 7. It should be 6 and 7, shouldn't it? Yeah. So it's not these. So. Okay, so the inverse properties, and let's go over those, and I've drawn some nice pictures here. So, we got x going into sine inverse. Or inverse sine. And x has to be in the domain of inverse sine. That domain of inverse sine is -1 to 1. And then these are composite functions. We're taking the sine of the inverse sine. So, and then that's going into sine. Well, what's the domain of sine? All real numbers. So, and then we get x back out. So, if you take sine of the inverse sine of x, that will equal x. For every x in the interval, we're restricted to the domain of this, -1 to 1. So, we have to be in that interval for it to work. Now, what if we do the other way? So I drew a picture of that. What if x is going into the restricted domain sine first? Well, our restricted domain of sine was -pi/2 to pi/2. And then we go into inverse sine, and we get x out, because their inverse sine, though, had a domain of -1. Well, when you take the sine, -1 to 1, but when you take the sine of a number, you're always going to get a number between -1 and 1. So we will get x out, but we have to make sure we're in -pi/2 to pi/2. And the same thing goes with cosine. You will get x out. These are inverses. For every x in the interval -1 to 1. Now, you get x this way, but now you have to, it's restricted to the domain of cosine is 0 to pi. And tangent, it's going to work for every x, because the domain of inverse tangent is all real. Okay. But when you go into tangent x first, that's the restricted domain. We restricted it to minus pi over 2 to pi over 2. Because we're going into tangent x first, we have to have that restriction. All right? And then we're going to find some exact values, and I think we're almost done, but I think well, we've got 5 minutes left. Let's look at this. Okay, so all that stuff I wrote up there is not going to make any sense unless we do some examples. So let's do some examples. Okay, so what we're doing, if you're taking inverse cosine of 0.7, is 0.7 between minus 1 and 1? Yes. So we can do that. And then we're going to take cosine of it. Well, we're between that and that, so we're just going to get 0.7 out. Okay, what if we, what's on this one, we take the sine of pi, that's 0, so we get sine inverse of 0, and we write theta equals sine inverse of 0. That means sine theta equals 0, but we have to be, for sine, we have to be between minus pi over 2 and pi over 2. So sine is, this equals 0. So that's a little tricky. We are, because pi is not in, pi was not in minus pi over 2 to pi over 2, so we're not going to get pi out. We're going to evaluate it. Sine of pi is the y coordinate over here, is 0. Now we're going to find the sine, inverse sine of 0. That'd be here. That's 0. It's a little tricky. Okay, let's try the next one. Minus 1.2. This is not in minus 1 to 1, so this is undefined. You could rewrite it as minus 1.2 equals cosine y. You can't take the cosine of an angle and get minus 1.2. And let's see, we're almost done, I think. But, okay, how do we find these? We're going to use a sketch and draw a triangle to find inverse sine of 4/5 first.
This is the homework, yeah?
Yeah, this is like the homework. Okay? What does this mean inside? This means theta equals inverse sine of 4/5, which means sine theta equals 4/5. Sine is opposite over hypotenuse. So we draw a triangle, make this theta, right triangle. This is going to be 4 over 5. What's this number? This is the 3, 4, 5 triangle. There's a 3, 4, 5 triangle that's handy to know. You could take 5 squared minus 4 squared is 9 squared, that's 3. But this is the 3, 4, 5 right triangle. So here's theta. Now we need to find cosine of theta. Cosine is adjacent over hypotenuse is 3/5. So we get an answer of 3/5. We never had to find theta. We just had to draw the angle and figure out the 3. This is another triangle here. This means that cosine theta equals 5 over 13. Draw the triangle. Cosine is adjacent. This is 13. This is theta. This is 12. This is the 5. There's a 5, 12, 13 triangle.
We can't see.
Sorry. Okay? So we found theta, and we found the missing side. Now we can find tangent. Tangent of theta is opposite over adjacent is 12 over 5. Okay? So it's the 5, 12, 13 triangle. So take a look at that, but the homework's not going to be due. That's how you have to do that homework. Okay, so we never had to find that angle. We just had to draw this triangle.